All right, let's get started. Again, my name is Marcus Brown. Joined with me today is Kyle Norman. We're going to go through talking about 3D printing in highly regulated industries. Specifically, there's two ways we want to look at this issue. There are going to be times when regulations from governing bodies are going to be against 3D printing, and we want to talk about how to overcome those challenges. But also we want to talk about how those regulations that are necessary for safety can actually be automated and improved using an additive industrial manufacturing tool for example, the Markforged Onyx system. So for the agenda today, we're going to go through this kind of on a case study by case study basis. And for each case study, we'll talk about the industry that we're in and the types of regulations that are there. We'll talk about justifications. So for example, what are the big problems? Where are the areas to improve? What is the challenge we're trying to overcome? And how does that translate into a business case? Because we're not here just to 3D print because 3D printing's fun, right? We're here because we need a more successful, more efficient, more profitable business operation. And then we'll take a look at the specific outcomes that customer in this case study was able to achieve, or just kind of talk more generally about what kinds of things you should expect if you're in that industry. And then we'll cover some real quick advice as far as getting started and how to address these regulations. Kyle and I work for MLC CAD Systems. We're a reseller of Markforged, SolidWorks, and Mastercam. We've been in business for over 40 years. We haven't obviously handled Markforged that long. They're not a 40-year-old company yet, but we cover everywhere in green and red on the map. We have locations and people there to help you with Markforged. So let's start with our first application, and that's going to be WÄRTSILÄ. So what WÄRTSILÄ needed was a way to pick up and move large boat parts for engines. And when I say large engine boat parts, I mean like pistons and crankshafts for cruise ships or cargo ships. And so these were really heavy steel parts. And what would happen is you would need to bring over a crane or a forklift to pick this up, but you needed something to attach to the part and give you a lifting point. So these lift mechanisms, they need to be available for different size ranges of parts, different shapes of parts. The ones that are normally available off the shelf are going to be metal, and they tend to be extremely heavy. So you're dealing with safety issues with the users. You're dealing with a situation where you've got to get additional equipment or spend more time with that equipment to get the lifting rig over to the part and then move the part. And these are going to be in different factories across the world, as well as on the actual ships. They need to be able to handle these. So a lot of room for improvement here. And as you can see, they did a 3D printed composite lifting rig that they got CE certified. So for the recap on WÄRTSILÄ, the main justification was that these lifting mechanisms were too heavy, making them unsafe or difficult or time-consuming to move to the part, let alone to then lift the part. They were having trouble with productivity because of that, and these tools were significantly expensive, and so they wanted something new lifting tools that were less expensive than what they could buy off the shelf. So the regulations are pretty generic. These are safety regulations that you would find in any workplace. In this case, it's primarily performance-based, right? You're going to put up a load test. For something like an overhead lift, you're probably talking 4 or 5 at least proof load, and if it survives that, then it's deemed safe for the working load. Generally speaking, these kinds of regulations are the easiest types because they're very general in nature. Right? The regulation doesn't say what material you need to make it out of because the material must be acceptable for your application. If your application has acid, you need materials that can resist acid. And so they're not dictating anything, but they do set forward general requirements. So what they did is they built these parts, they did the testing, they submitted them for certification, and they became CE certified. The parts, the finished assembly, was 75% lighter than the off-the-shelf tool, meaning they don't have to bring any equipment over to move this thing around. It can be carried comfortably and safely by a single user, a single worker. They can put it in place and then be ready to lift and move around as needed. Because just simply the cost of the materials, or the cost of those lifting tools from off the shelf, they were able to save 100,000 euros in 8 months. Just in that term right there, not to mention the productivity of things like the cranes moving around or waiting on these really heavy lifting mech tools to get attached. They did a 100% digital inventory, so they could print on demand. What that means is everything that they design and get tested and certified gets loaded into the Eiger software. That's the Markforged slicing and data management tool. We'll talk a little bit more about that, but basically you don't need to stock these things ahead of time. If you know that one of these parts is going to be in your shop, you can print the tool you need on demand when you need it, and only how many you need. And if anything happens to it, you can print a replacement part, or you can print an entire new one. They're actually not only putting these printers in each factory so that they'll be able to print wherever they need it without having to ship these things around from a central location, but they also plan to implement these on ships. So for maintenance and repair operations, if they need to move a part around and they're already underway, they can simply print what they need on their local printer on board and be able to maneuver it around. It's a pretty amazing story, and really talks about the benefits of just additive in general, and how general safety certifications should not get in your way. Kyle, why don't you take this next one?
Yeah, thanks, Marcus. Okay, let's look at the next highly regulated industry, and that's aircraft. The example we're going to look at today is cabin management solutions. These guys repair, replace, and upgrade cabin comfort systems in luxury jets. So pieces and parts that go inside of your VIP Gulfstreams and stuff like that. These guys do everything from overhead reading lights all the way down to full cabin audio-video systems. Believe it or not, some of the audio-video systems that come in these multi-million-dollar jets are not that great. So these jets will be purchased and flown directly to these guys for upfitting of nice audio-video systems. When cabin management solutions began to look at additive solutions that would fit their needs, the things that they were looking at was ultimately, hey, we're producing low volume parts, right? Not very many parts at all. All of these parts obviously have to be able to be FAA compliant. Plating is a must. So as you see in this graphic here, those are actually 3D printed onyx parts that were gold plated. They figured out how to electroplate all of the onyx parts, and basically had to all meet the FAA requirements. As they began the journey, Markforged helped them down this journey, and ultimately Cabin Management Solutions has in-house testing and a in-house FAA representative. So as they headed down the path, they were able to test in-house and ensure that all of the materials, pieces and parts that they designed met the smoke and fire and toxicity requirements that the FAA had, as well as like the traceability and stuff like that. So when cabin management started looking at Markforged, the justifications were the high part or tooling costs for creating injection molds for each and every one of these parts to mold these in a FAA approved material. But there were complex shapes that included undercuts, stuff like that. It ruled out a injection mold just because of tooling costs and long lead times for that. And then ultimately they were not an injection molding house, so what that meant is they had to machine every single one of these, and even machining or injection molding, your supplier would have to be FAA certified to handle the material to continue that cradle to grave traceability that's required by the FAA. Speaking of FAA regulations, you have that smoke and flame retardant. They were able to do the tests in-house, so they have an in-house fire testing booth. They actually have many of the in-house FAA testing requirements right there so that they can do all kinds of testing. The FRA material met all the material traceability requirements for the FAA. And then process repeatability, this isn't necessarily something that we thought about before, but the Markforged ecosystem allowed them to prove process repeatability and documentation just by the control of our software, our materials, and our machines all in this closed loop environment. And then outcomes of this implementation were the X7 industrial printer fleet that Cabin Management Solutions is running created 100% digital inventory. So they didn't have to keep pieces and parts in inventory. So like, for example, if you were to injection mold pieces and parts, you're going to have a minimum quantity, usually in the hundreds, if not the thousands. And that just didn't make sense for them. Fast turnaround, it was a competitive differentiator. What this meant was they could fulfill customers' requirements faster, and ultimately they could quote more jobs, which meant landing more jobs than their competitors. And then once again, the Digital Forged helped Cabin Management Solutions to meet all FAA compliance in order to get these pieces and parts that are in flight today approved and stamped by the FAA for in-flight use.
All right, so here's another one in the aerospace industry, but with kind of a different slant. Probably the reason we're hitting the aerospace industry so hard is because Markforged has made very specific accommodations to meet the aerospace industry. And in this case, they wanted to talk more specifically about inspection. So Hangar 1 Avionics, they make avionics, they perform maintenance, repair, and installation services. And for every part that's going to go on an aircraft, you have to do a separate inspection of every piece. That means you've got to have not only the equipment like the CMM, you've got to have the tooling to hold your specific part, you've got to write out a process to make sure it matches up with the quality requirements for that part, and it has to be manually performed by a user every single part. So that means you got upfront costs to set up the inspection routine, and then you got ongoing costs for the inspections for each piece. They're building these parts traditionally on a CNC machine, which is fine, right? It's a great way to build low volume parts, but when you start to talk about weight savings, right, you're cutting metal, and it's hard to get weight out of a metal part. And a lot of times, to save that weight, you're making it a much more complex part to program. So what they wanted to do is save weight and automate the inspection routine as they go. So what they looked for was something that would automate the inspection. And so they found Blacksmith on the X7 Industrial Markforged printer. What it does is it has a laser down with micron level precision, and that laser will help you not only level the bed and kind of automates the setup of the machine, but it also does a fantastic job of sort of inspecting the part as you go. Layer by layer, or every certain number of layers, or certain key features, it will scan as it goes to make sure that it is meeting the tolerances that you've specified. And this includes things like interior shapes that are hard to get to, shapes that are in weird orientations that would require multiple setups on a CMM traditionally. This is going to do all at once. And by the time the part is done and you're ready to pull it off the print bed, you're also going to have automatically an inspection report created and stored in the cloud. So not only does it automate the inspection report and give you very visual results, it also helps with the data documentation and retention policies required by the FAA. So, real quick recap, right? The inspection documentation and the performing of inspection processes is costly. It's difficult to achieve repeatable accuracy depending on what the part is and how much complexity is. It adds cost. Sometimes the features can be difficult to inspect. And what we're dealing with is the entire range of FAA compliance. But specifically, what they found was they were not stopped from doing this by any stretch, but they were definitely helped in the process of inspecting the pieces and helping with documentation and retention requirements. So if there's ever an audit, they can say, yeah, tell me which one you want. It's right here. I can pull it up from anywhere that I have secure login to my system. So the outcomes, they actually did a heads-up test between their traditional methods and blacksmith, and they found that blacksmith is faster, easier, and more reliable for the employees, for the users. So they were going to be able to save time and money on every single part as well as the initial setup. With the cloud-based document control, their automation retention policy and their document creation is automatic as well. And they found that blacksmith, depending on the size of the part and everything else, was more accurate and could traditionally get within 3 to 4 thousandths anywhere, any feature, they'd be able to measure the accuracy down to that level. Kyle, this one's right up your alley.
Hey, yeah, thanks again, Marcus. So let's talk about another regulated industry that has begun to see the benefits of additive manufacturing, but I think we've only scratched the surface here. So let's talk about oil and gas. Oil and gas is regulated by the American Petroleum Institute. So API regulations basically run everything in oil and gas. They give you manufacturing specifications. And the reality is the big three came out and said safety is a non-negotiable item in this industry anymore, because the reality is if a part fails, people actually die. And that was no longer an acceptable outcome for the big three oil producers. And so they said, any of your suppliers have a lost time accident, we will no longer use you. So to pretty much change the industry, and the industry is afraid to deviate from any of these API standards. And the secondary part of that is API really hasn't made any allocations for additive manufacturing as of yet. So it means that people in the oil and gas industry are hesitant to use 3D printing, even when it's in an application that's not even applicable, if that makes sense. The technology is just a little new for API and in the grand scheme of things. But when we look at applications like offshore drilling, where you're talking about an isolated island, it's an island out in the middle of the ocean. They can't get pieces and parts. They can't keep a huge stock of replacement parts. And even though the part is just on shore, it's really only 30 or 40 miles away. It might as well be on the other side of the planet, because it's going to take a few days for it to even get out to the platform. And when we're talking about downtime on a drilling rig, we're talking about millions of dollars per hour. So if they're able to produce non-consequential parts there on the platform, it's a game changer. And we're beginning to see some of these things, even simple things like knobs, levers, check fixtures, spacing gauges, stuff like that aren't necessarily pressure bearing. It has really began to take off. It's still kind of small things. It's really manufacturing centric. So pieces and parts to aid the manufacturing part of the process. Things like jigs, tools, and fixtures. So let's go at a quick recap of oil and gas. So justifications become, in the oil and gas industry, oil and gas is extremely cyclical. At one point in time, you could actually almost set your watch by the cyclical demand of oil and gas. And what this meant was it kind of required a rapid response, the ability to respond to what the market needs, what the people in the field need as quickly as possible, because this is a short window. What we need to do is be able to get in, make our money, and get out. That led to solutions for the large, complex shapes, pieces that are hard to maneuver in manufacturing. So jigs, tools, fixtures, stuff like that in the manufacturing facility. As far as regulations that they're trying to work with, parts that don't hold pressure don't necessarily have to be compliant with those type of regulations, but yet oil and gas is extremely hesitant to deviate from any of those API certifications. So as written today, any of those certifications disallow additive in-use parts for pressure bearing vessels, stuff like that. But time is going to change that. We're going to see changes to that because obviously additive is moving at an extremely high rate of speed, and things are changing quickly. What we'll begin to see is a larger adoption and larger allocations on the standard side. What are they seeing? Even with the technologies today, what they're seeing is shortened lead times. What this allows them to do is take advantage of those demand spikes. So if they can get to the market faster, that all equals money. As well, increasing manufacturing productivity. So be able to create those jigs, tools, fixtures, the inspection fixtures, assembly aids, gauges, and stuff like that has really accelerated the manufacturing process, because additive manufacturing isn't just for end-use parts. One of the biggest uses for additive manufacturing is but basically manufacturing assistance. With that, I'm going to hand it back over to Marcus.
Yeah, so let's talk about the military. In this case, this is the U.S. Marine Corps. And a saying from Eisenhower was that wars have been won or lost primarily because of logistics. And we see a lot of that in the war in Ukraine and elsewhere. And so what they were looking at is specifically maintenance and repair operations. If they needed to get a part into a theater, right, into the war zone, it could take months to get it there. And that could be because they need to create the part, ship the part, get it actually to the unit that needs it. So there's a lot going on there. So with that slow supply chain, they really needed a better way to create not only faster response for their maintenance and repair operations, but also more robustness and kind of some redundancy. And the Markforged printers give them the ability to produce parts that are strong and durable exactly at their point of need or very near their point of need. So the way that that's possible, and we've kind of discussed this cloud before, is with the Eiger platform. Eiger is the world's largest fleet of online industrial printers, and it takes data from all those printers and it feeds them to an artificial intelligence algorithm. So it's not looking at your parts and sharing those parts with others, but if you create a special part and it warps in a weird way just because of the nature of how it's printed, the AI can learn from that and can improve. And so the system is constantly getting better at all times. Not only that, because the system is all one ecosystem containing hardware, software, and materials, everything is going to work together really, really easily. It's going to be bulletproof. So if you source your material from Asia, you got your machine from the United States, but you're using it in Europe or the Middle East, you're still going to be able to confirm that the part that you get off of this system is exactly right? You're not going to have deviation from the original design just because it was fabricated somewhere very different. It's a controlled system with verifiable outputs. And not only that, let's talk about mil-spec and kind of how that works. So mil-spec requires a whole lot of requirements, very much like the FAA would. Things need to be strong enough, things need to be durable enough. But what you might find is that at the end point of need, they come up with an idea to fix something that broke or to upgrade something or to equip something, and they just print it with their best guess and they put it into practice. Right? If you've got a machine down and you have the ability to get it back up and running again with an untested part, that's worth it. You're going to try that. But then through the cloud, you'd be able to share that with designers, testers, other military personnel, anywhere else in the world that are connected to that account, and they could then test it as well. So they could put it on a test stand, run a physical test, and then say, yes, that's going to meet the needs, and basically mil-spec it after the fact. Or they could modify the design. So if you need something that's really lightweight and easy, you can make it out of onyx. Onyx is a really durable plastic, but it's not as stiff as metal. If you need something as stiff as metal, you can impregnate it with carbon fiber. It creates a skeleton through that part. If that's going to be too stiff, let's say the part broke originally because it was made of metal and it didn't have a lot of give. So something with a little bit more toughness and less stiffness might be better suited for that application, you could put in there Kevlar. Kevlar is not quite as stiff, but it will absolutely take a lot of damage. It will take a lot of deformation, and it'll still hold on and create a really durable part, which obviously is why they make bulletproof vests out of them. So to kind of recap this, the needs for the Marine Corps are pretty obvious, right? Troop safety, combat effectiveness, and for maintenance and repair operations, that means keeping their equipment running at all costs. The problems were that the supply chain speed and lead times were really long and slow, and if there was kind of a non-standard break or a kind of an adaptation that was made out in the field, you had a really hard time connecting somebody that could do the design and testing with somebody out there in the field that's a user. And so by using the platform, you can kind of connect all those together. So the mil-spec components require a lot of testing and validation, a lot of supplier certifications, but these field units don't have the luxury of, getting access to mil-spec components, right? So it becomes sort of an optional mil-spec when you're in an emergency situation, but you want to regain or retain compliance as much as you possibly can. And so what the outcome was, this was actually a kind of a cool story. The military came and said, look, the X7 is the perfect tool for us. We love it, but we want something that is much easier and faster to set up. So they created the X7 Field Edition. And the way it works is it's basically pre-packaged in a Pelican case. You drop it on the ground or pull it out of the back of a truck, pop the top off, give it power, and within just a couple of minutes, it's ready to print whatever it is that you need. That means that they don't need to keep on hand quite so much inventory, right? They can almost just decide not to bring any inventory for things that they know they can 3D print and meet specification. For anything that's going through this system, you have the ability of using the military grade cloud security, but it's not going to be anything on the cloud's just not going to really fly with ITAR. So there is a 100% offline mode as well. So you could ship this X7 Field Edition with a whole bunch of known, ready-to-go parts out into the field, and they would simply find the one they want, pull it up, hit print, and they're assured that they're going to get exactly what they need out of that printer that looks just like it was when it was specified or certified originally. So how would you get started, right? If you're in an industry that's really regulated, you may be looking to sort of automate or streamline and improve the overhead of these regulations, but you may also sort of be trying to fight those regulations. So first thing I would recommend is read the standards. You probably have to read them again, specifically thinking about additive manufacturing. Does it give you a specific material type? Does it require a specific process to build it? Are there repeatability or certifications for suppliers, things like that are needed? What testing is necessary? If it's a load test, great. We should have no problem with that. If it's a chemical test like a salt spray, assuming we are, have a suitable material that will resist that fluid, should be no problem. We're a little bit limited on materials relative to what you might do with an injection mold. So definitely take a look for any key, red flags there. Look around your industry and look for past examples, right? If you are certifying something and you believe that they may be concerned about it, this is a perfect example was FAA. Cabin management knew that this had been done before, but it hadn't been done in a very long time. So they cited that previous case and said it's just like that, but like this. And it went on through. So if you're the very first one, you might have some unique obstacles and a larger, higher barrier. But once you get in, the rest of them are going to be much simpler to achieve. And anyone else from that is going to be able to take advantage of that opportunity. The last thing I would say is don't hesitate to reach out to these regulatory bodies. Technology never stops, right? These standards are going to lag that technology. they're going to say, hey, I need to be conservative, so this looks like a cool technology, but I'm not ready to jump in there and say it's totally suitable for, worker safety parts, load bearing, pressure bearing parts. But they do have a duty to stay up to date on what is needed in the industry. So we're seeing a lot of activity where people are saying, hey, you always want us to use these hand calculations to check for safety, for example, on a pressure vessel code. But could we do FEA that would be more adaptable to complex situations and scenarios? And so they're working to rewrite these standards. It's always going to be slow, but it is possible to make progress once the need is found and everybody is kind of the consensus that it's going to be of value. So I hope that was informative and helpful.